Hey folks, welcome back. This is Joel, and in this video we'll talk about a couple of interesting Arista's features. One is the MLAG and the other one is the virtual ARP, or sometimes called VARP, right? Over the last couple of months I've been playing around with the EOS CLI, and I thought it's probably time for me to start putting out a few labs, right, over the next few weeks or few months, surrounding the EOS CLI and some of the interesting designs which I get to play around, right, regularly. So that being said, let me just quickly jump onto my screen. Yeah, so I've got like a very simple topology down here, right? And again, I just want to reassure you, the terms MLAG and VARP, if you're really not familiar with it, don't worry. I'll take a couple of minutes to talk about it. But at the same time, this is, to be honest, not something completely new for the networking world, right? So we have in fact done something similar, with different vendors, right? On the channel before with this Cisco CLI, with Aruba's CX CLI, we got similar options over there as well, right? I think let's dive into it, right? So what's this MLAG and what's this VARP about, and what's the use case here, right? Let me just pull out my whiteboard here for a minute, right? So you see, typically, right, let's take a typical scenario, right? Hope my pen works here, right? So in a typical scenario, what really happens is, so if you've got like, say, you've got a switch, right? Let's say you've got like a couple of switches. Maybe this is your distribution layer and this is your access layer. I'm just going back to your typical, campus deployments, right? How do you get any sort of redundancy here, right? One of the first thing which you can do is obviously introduce links, right? You introduce multiple links, do like a port channel over here, right? So that's basically giving you link redundancy, right? But again, this is still not giving you like any sort of box redundancy, right? So the moment you need a box redundancy, what you would do is you would probably end up doing something else. You should probably add one more box here, right? Or one more, when I say box, I mean a switch, right? And you would probably go and connect these guys over here this way, right? This is how you would do, right? And you would probably need a L2 connection between. So this is typically how you would do. So you've got an access layer and you've got the distribution layer, and this is a typical connectivity which you would probably find in a campus or a data center setup. But the problem with this, I think, if you've worked a little bit on the networking side, you know that the moment you see this, you see a loop, right? So you've got your box redundancy, you've got your device redundancy, but then you have a loop. The moment you have a loop, your STP is going to come in and is going to block one of the link, right? Probably this one or this one, whichever, right? So you're losing the bandwidth on one of that link, right? So what did some of the smart people come up with, right? What they ended up doing was, they thought, how about I kind of, let me just use a different pen, right? So how about I kind of take both of these boxes and kind of logically put them as, or combine them into a single box, right? So what this would logically look like would be as simple as this one, right? So these two boxes would just combine into one box, and then you've got this guy, right? And typically it would just end up looking like this, right? Or if you have 4 links over here, it would probably look like this, right? But you get the gist, right? Now if you see here, you don't have a loop, right? Because this is all one single port channel. So from this switch, as you're looking up, it just appears as if you're just connected to one more switch on the other side, though it's 2 separate switches, but it appears as if you're connected to one single switch, and you can port channel all those interfaces, thereby giving you everything what you need. You're getting box redundancy because you've got box 1, box 2. You're getting link redundancy because you have multiple links as well. So all your problems are solved, and there is no STP. I mean, there is STP in the background, but it is not really doing anything. It's not blocking any links. So you're getting the full bandwidth, right? So this kind of concept is present, across vendors, right? In Cisco's world, we used to call it as your VPC does something similar. In Aruba, we used to do something called as VSX, right? And in Arista, we do something again. I mean, accomplish this something similar, right? Might not be the exact code base, everything which is used in the background, but the goal, right, is basically your it's basically called as MLAG, right? And it's very intuitive, right? MLAG, M basically stands for multi-lag. So you're basically doing a lag, right? Here, in fact, you're doing a lag between 2 different boxes, right? Box 1 and box 2. So this switch is able to do a lag between 2 different boxes, and that's why it's MLAG, right? So that's the understanding, and we'll obviously do a CLI configuration to kind of set this up. While we are here, the second topic, let's also discuss the second topic, right? So let me just see if I can clear all of this out. Yeah. All right. The concept of VARP, let me just grab my pen here, right, is nothing but what we call in the industry as anycast gateway, right? Anycast gateway is a more familiar term we probably have heard of, in the routing space or in the IP space. But at the end of the day, VARP is nothing but short for virtual ARP. It basically does the same thing, right? So again, just to take an example, say you've got like a box 1, box 2, and maybe let's say another box 3, and basically I mean switches, right? And again, for a minute, let's forget about MLAG and stuff like that, right? You have a very simple setup, something like this. You've got like, you've got like, say this is the access layer, you've got the distribution layer, so you've got 1 and 2 switch, right? Now to do like, and say you've got like something like this, okay? So now if you want to do something like, first hop redundancy, right? Your gateway, right? So you've got like, say a VLAN, say you have like, maybe like a VLAN 10, right? And you want to provide the SVI gateway, right, at this layer, then one of the common way we all probably do this is using something like a HSRP, which is a proprietary protocol, or VRRP, right? This is how you do it, right? So, but in the VRRP, the idea is that you make one of the switches active, other one is the standby, right? So the traffic always traverses, from the active, and if the active box goes down, then the standby takes over and things like that, right? So that's how your HSRP, VRRP work. But again, the drawback of this is that just one of the box will always be receiving the traffic, whereas the second box is always idle. Now, with the anycast gateway approach, right, we kind of try to solve this, right? So with anycast, what really happens is you don't have this, get rid of that. So let me again go back to using an example. So if you have, for example, if you have the VLAN 10, what you can do is you can probably, let's assume that the gateway IP is something like 10.10.10.1. So you configure the same IP as a virtual IP on here, as well as over here, right, on both the boxes. Similarly, you also have a virtual MAC address, something called as MAC A, right? I'm just giving an example, but the same MAC address is configured on both the boxes this way, right? So now what really happens is, say you have an end host connected here, and this guy is trying to do an ARP for the gateway, which is this guy, right? When you're doing an ARP, the IP, you're trying to get the MAC address, right? So if the ARP reaches this guy first, right? So this guy is going to reply back, with this mapping, or if it reaches here, he's going to reply. So both the boxes, independently can forward the, can basically reply to the ARP request and forward, or basically at the end of the day forward traffic, right? So both are working in a active fashion, right? The only thing is you might have a question, can both the boxes advertise the same IP from two different places? Yes, and I believe Arista kind of in the EOS, they kind of take care of this, right? You basically, bottom line is that you don't get any errors which says that, okay, you're using duplicate IP, right? So you don't get that, though all of this is in a single L2 domain. You can use the same IP in two different places and you don't get that errors, right? So that's one thing. And second thing is how this really plays out in the MLAG scenario, right? So if you have some sort of a MLAG, so let me go back to getting rid of this once again. So maybe let me just, yeah. So now let's say you've got the MLAG also into the picture, right? So which means this is some sort of a port channel, and because this is the MLAG, you probably are gonna have like both of these boxes, right, are basically going to be a in a MLAG, right, something like this. So again, how does this work? Pretty straightforward, right? So the ARP request basically travels on the port channel, right, and then the MAC address, whatever is the virtual MAC address, is learned on the port channel. So on this particular switch, if you see the MAC address table, so it will say that to reach this MAC address, right, use the port channel, I don't know, maybe 3, whatever, right? So you see it plays out pretty well, right? So you're here because you have a port channel here, the traffic can again go on this member interface or this member interface and finally land upon one of the switches, right? And again, both the switches, like I said, are configured to answer the ARP request, and you get the reply back and the traffic flows, right? So this is more of a VARP or anycast gateway is more of a adjacent feature to your HSRPs and VRRPs, but the advantages being both the boxes are active, both the boxes are forwarding. You don't have to make one of your boxes idle, right? So you basically get the full benefits of all your links. At the end of the day, that's very important, right? In a campus or data center network, you've invested in your switches, you've invested in your links. You basically want to get the maximum out of them. Use MLAG, use VARP, right? Again, like I said, VARP is something which you don't really need to use it with MLAG. You can use it independently as well. It's just that, maybe on this switch, you might see the MAC address continuously switching between this link and this link, right? Because you might be learning the MAC address, the virtual MAC address, either on this link or this link. So you might have to tune your timers a little bit over here, but there are ways to do that. Or if you're using in a MLAG scenario, you don't even have that problem because the MAC address basically gets learned on the port channel, right? So it will always be the same port channel. All right, so enough of all the theory. I'm gonna quickly jump on to like setting this up or configuring this, and probably look at a couple of packet captures to kind of solidify the learnings, right? All right, the configuration is pretty straightforward. So I'm gonna pull up my CLI here, right? So these are basically the switches, just to give you the topology understanding, right? So there's a couple of switches here where we'll be doing MLAG, right, between D1 and D2. I also have all these the uplinks, right, the Ethernet 5 and Ethernet 6 from both the switches, as well as there's one more switch on the top. All these three switches are basically on these two links. I've just put IP addresses, point-to-point links, right? I'm using the 13.0 network here, 23.0, and I've also put a loop back over here, and I've just put a routing protocol. Basically, OSPF is running on these two links, so that we get the routing, right? But the routing is of not major concern for us right now. We just want to set up the MLAG between these two switches, and also want to set up VARP. So the VARP will basically obviously use the configuration of we'll be using VLAN 10, and the subnet is going to be 10.10.10.0/24. The VARP IP will be this, and the VARP MAC address. It can be anything else, but I'm just using this for this configuration, right? All right, so let me pull up my CLI. So I've actually done the configurations already, so I don't want to like really sit and waste time typing down here, but I'll just take you through the various snippets which I needed to kind of get this thing working, right? So to start off with, like I said, where we are going to set up the MLAG, right? And what we really need to do is we need something called as a peer link, right? Again, this is a strategy which is used by all the vendors out there. So you need a peer link. And generally recommended is to kind of have like a port channel. So in our case, as you see here, the Ethernet 1 and Ethernet 2. So we're gonna do a port channel between these two links, call it as a peer link, and we're gonna allow this peer link to be the pathway for both the switches to communicate and exchange the states and databases, so that they both act as one single switch, right? And for that purpose, we before even we create a peer link, we need a VLAN, right? We need a VLAN which will work on this peer link, or which will run on this peer link, right? To kind of to help us provide the segmentation, right? So in our case, I believe we have used VLAN 4094, right? So I've just gone and created. In fact, let me just show you the full running configs, right? So if you see here, this is what we've got. Just pull down here. Yeah. All right, so this is what we've got, right? So we have created a VLAN 4094 specifically for this purpose. The second thing is we also need what we call as, again, this probably might be a little this might be a little different, or this is something which is not very common. You might have not seen with other vendors. Arista uses something called as a trunk group, right? What is a trunk group? Yeah, it is just a VLAN filtering mechanism, right? So what we really do is the moment you create a VLAN and you assign it to a trunk group, by the way, this name, in my case, I'm just calling it as a MLAG peer, right? So you see I've created a trunk group called MLAG peer, and you can see that I've gone and attached that MLAG peer to the port channel PO10, right? And what's a port channel 10? Port channel 10 is basically the peer link which I'm talking about between those two links. Because if you come down, or if you look at my topology, you can see the interfaces of importance are Ethernet 1 and 2. So if I look at Ethernet 1 and 2, you can see that's the port channel 10, right? So Ethernet 1 and 2 are basically port channel 10, and the port channel 10 is tagged to this trunk group called as MLAG peer, and this trunk group is then tagged to this VLAN, right? What does it all mean is that the VLAN 4094, right, is not allowed, right, on any other interfaces or any other trunk interfaces, because it is attached to this trunk group, and it can basically be used on the port channel which is mapped to this trunk group, which is MLAG peer, right? And that's basically in our configuration, it's only port channel, right? The reason we do this is obviously just to kind of make sure that that particular VLAN is not allowed anywhere else in the network, and thereby we can prevent any sort of spanning tree protocol causing a loop. And that is also the other reason. What we do is, what we recommend generally is that to disable spanning tree on that VLAN. As you see here, no spanning tree 4094, right? By doing this, what we are really achieving at the end of the day is you're making sure that the peer link, any of the links are not shut, right? That's what you're achieving. You don't want spanning tree to come and shut one of your link because of misconfs, right? So that's why we are explicitly telling the we are explicitly defining what is the VLAN which we are going to be using for our peer link, right? Which is 4094, and we are making sure that VLAN is not used anywhere else, right? By using the trunk group configuration, which is a bit nascent or something new to you might have not seen it being used a lot in other vendors. Okay, so that's something new, right? And so that's so what we really did was we created a VLAN, right? Attached it to the trunk group. Then we went about creating the port channel 10, right, which is comprising of Ethernet 1 and 2, which is these two interfaces, right? And the switch port is more trunk. You can obviously for the peer link, obviously make sure that you use the VLAN filtering mechanism of trunk group, right? Because this will help you to kind of make sure that 4094 is restricted only for this port channel, only for this trunk, and nowhere else, right? And the last part is your MLAG configuration. Right? The MLAG configuration is important. So the MLAG configuration, again, you have to do whatever I'm showing right now. I'm showing on D1 and D2, right? So on D1, again, you need to define something called as a domain ID, right? It's a unique identifier which you use for a particular domain, right? So you gotta use MLAG 1 on switch 1 and switch 2, right? So it has to match. So you've got the domain ID. The local interface, right? Again, is the 4094. That's the VLAN, which is going to be used for all the MLAG communication, right? So that is what the VLAN which we created earlier. So we need to map that. Doesn't have to be 4094 always. You can define always. You just need to create that VLAN and use it here, right? Then you also need to define the peer address. So by the way, probably I missed that part. If I show you here, if you see here for the interface 4094, I've also gone and kind of created an IP address. Right now, this IP address doesn't have to be routable. It can be routable any random IP, because it's just a point-to-point link. You're not going to kind of advertise this 4094 in any routing protocol, right? You don't. There's no necessity for it. So it can be any dumb IP. It can be 172, 192, whatever, right? Any private, any unused IP address, or even if it's used any other place in the network, you don't have to worry, because we're not gonna route on this, right? So I'm just using a 10.0.0.1, and on the other switch, peer switch, I'm using .2. That's why you see there's a peer address which is defined, right? All of this configuration is just basically telling my D1 that, hey, look, this is your peer, right? So I'm saying this is my peer, which is D2. This is my source interface from where, all the MLAG packets or the MLAG information is going to be sent across. And then again, just like all other vendors, right? You also have what if this peer link goes down? Then you might have, because of some issue, maybe the peer link is down. You might have a situation of active, right? So where both the boxes, right, might kind of because at the end of the day you want D1 and D2 to work as a single system, right? But if the peer link is not know what's happening with the other device, so there is a, let's say, out of the band way to kind of make sure that the other device is up, and that's the heartbeat method. So again, for this one, you can just use a routable IP. In my case, I'm using 10.10.23.1, which is basically this IP over here. So I'm on D1, I'm just saying that use this, L3 IP, right, of the other guy. So it's just like a fallback mechanism if your peer links fails. You can again read up a lot about MLAG and VARP on the Arista's website, but that's basically the whole point of the MLAG configs. Okay, so that's the MLAG config. So right, pretty straightforward. And like I said, on the top I also have routing. Routing is pretty straightforward. I've just put router over SPF and advertise the two subnets. One is the 10 network and the other one is the VLAN subnet, 10 subnet, right? So that's all your MLAG configuration, right? Now coming to the VARP, which is also important. If you see the VARP configuration, it's pretty interesting. Again, you see VLAN 10 is over here. The VLAN 10, what I've done is the physical IP, I've given it as 10.10.10.2, but you see the virtual IP is 10.1. You can send IP address. And then you also have something called as virtual MAC address, right, which you can define, right? Now this one and this one will be the same on both the boxes, right? Whereas the physical IP will be different. Here it is .2 and the other one is .3, right? So that's it, right? As simple as that. So that's basically that. And then the last part is, so we have done everything between the switches. We have talked about everything above. Maybe what is happening below, right? Below you just need, so what is happening with Ethernet 3? Let's Ethernet 3. If I scroll up, you see Ethernet 3 is over here. 3, and this is basically going to be a normal port channel, right? Because now that both of these systems are working as one single system, you need to define your LSAP port channel. That's what you see here. Switch 1 mode, switch, say Ethernet 3, mode active, and same thing if I do on the other box, which is secondary box. You'll basically see, okay, give me a second. Yeah, so on this one again, if I have to configs, right, mimic almost the exact same as what we did on the other box. So you have 4094, you've got trunk group, right? I've just used the same name. You don't have to really use the same name here. I've just kept it same. Remember, I also need to disable spanning tree over here on the 4094. I've done that. The next is pretty straightforward, which is the port channel 10, right, which is the peer link, right? Make sure that these two interfaces are part of the port channel 10 using this config. And next is the MLAG configuration, which you see here. The domain ID is kept same as the first box. Local interface is 904. Peer address becomes the peer address of D1. This is also the heartbeat address of D1, which is here. And then I'm defining what is a peer link, which is port channel 10, right? Coming to the VARP configuration, you've got the VLAN 10. You can see the IP is .3, virtual IP is this, virtual MAC is this. Straightforward. And the last part is, like I said, routing. So I'm using routing here for the uplinks. So you can see the 10 network, 23 networks has been advertised. There is routing in place as well. Cool. So that's mainly it. And from a downlink perspective on the Ethernet 4, I will just have Ethernet 4, right? And as you can see, you've got where is this? So Ethernet 4 is here. I've put it in port channel 3, and then under the port channel 3, I've called it as MLAG 3, right? So that MLAG 3, same thing on the first box as well. By defining the keyword MLAG 3, right, you basically are telling the switch that, okay, look, port channel 3, which is the port channel towards your access switch, that is your MLAG port. Now from an access switch or A1 perspective, this is not a problem, right? So if I show you that from the A1 perspective, it doesn't even know what a MLAG is, right? So here the configuration is nothing. I mean, to be honest, it's just saying that Ethernet 3 and 4, put it in normal trunk, right? Trunk and mode active, that's it. And port channel 3, right? Very straightforward, simple, right? So from a switch A1 perspective, you don't even know anything about MLAG, nothing. So your MLAG construct just lives only with D1 and D2, and these are the set of configs to make it work. Okay, now to just quickly verify that things are working, right, I also have like a packet capture running in the background, right, because there's something interesting I want to show you with the packet capture. That's why I have it running. But before I quickly show you, first of all, let me ping the default gateway, which is 10.10. So this is the host, right? So I'm here right now. Here I'm gonna ping the VARP IP. VARP IP is 10.10.1. Right, there you go. Ping is working. True. And let's see if I can ping the outside as well, right, which is 99. There you go, that works. So connectivity is up, right? Now kind of quickly to show you the packet capture. I don't know if I can show you that here. That very interesting you know way people kind of do solve a very interesting problem which I want to show you. But before that, show you packet capture, right? So what really happened when I did or let's probably look at the MAC address tables actually, right? So let me show you. So this is basically the virtual IP virtual page ending with 0099. So if I go on to my access switch and if I pull up the MAC address table here, you can see that particular MAC address table gets learnt on the port channel 3, right, which is the port channel towards the towards the two switches, right, which is fine. And if I probably go on to my host and if I look at show IP ARP, you can see this particular IP is associated with that virtual MAC address, right? This is the virtual IP, this is the virtual MAC address, and on this host I have basically made my the default gateway is nothing but the virtual IP, right? So that's how the connectivity is all working, and you saw the MAC address being right. So great. So one last thing, I mean, just to show you, because I did the ping, right? So if because I did the ping, you basically saw that, and I'm basically using like I said, I'm using MLAG, right? So or maybe let's do the ping once again so that you can see this happen in the background, right? So I'm gonna just pull this down maybe over here, or let's see if it, okay, I'm gonna pull this onto my other screen because I don't have space. I'm gonna do the same ping again, right? So I'm gonna ping the default gateway. There you go, and you can see the ping packets over here, right? Something interesting to note here is, so I mean, obviously the ping packets are going to flow on either of the links, right? So I'm doing a packet capture on the two links, this link, because that is in port channel, hashing works and only one of the link gets picked. So that's why you see packets on only one of the link. But what I really wanted to show you here is, so if I picked a ping request, right? The ping request is going from which is the host, and let's move this up a little bit. And I don't want that, so I'm going to pull this. Okay, so that's the source IP going to 10.10.1. You can see the source MAC address is that of the host, and the destination is the virtual MAC address, right? But something interesting to note here is the reply which comes here, right? When you see the reply which is coming from the gateway host, you see the source MAC address is not the virtual MAC address, right? So this is the physical MAC address. This is actually the MAC address from the D1. In fact, if I go to show probably interfaces VLAN 10, there you go, right? So this is the MAC address, what you see over here, right? E00B. So something interesting to note here is the virtual gateway, right, which is present, never uses the virtual MAC address in the source in the source of the Ethernet header, right? So this MAC address is always used only in the destination, right? So when the switch replies back, so if you're sending a traffic directly to the switch, and if it has to reply back, it basically uses its physical, the traffic is redirected to its physical interface, right? Physical VLAN 10 IP, right? And from there a VLAN 10 interface, right? And that's why you see the reply which comes, it basically comes from the physical MAC address and not from the virtual MAC address. Something interesting to note, right? So that's something very interesting, and that's kind of another kind of like a very interesting observation, because what really happens is, or maybe let me just take my whiteboard to explain this, clear this out, right? So if I probably take my pen here again to explain the scenario, right? So you've got a couple of switches, you've got a switch here, and then you have an end host here, right? Now from the end host, what we really did was, and again, you've got things like this, and you've got things like this, and you have the MLAG, right? All of this is the setup which we've got, and then you have the end host connected here. Now let's say from this end host, I'm trying to do a ping to 10.10.10.1, right? So that's the gateway IP, right? So when I'm doing a ping to this, first time obviously there is going to be ARP request which is going to go, right, and one of the switch, either of these switches, right, is going to reply back, right. So that time obviously this particular switch will learn. Let's again, for simplicity, let's assume that the MAC address is 10.10.10.1. The corresponding virtual MAC address is, let's say, A, right, just for example. So obviously, when the ARP request goes like this, there will be an ARP reply coming back, and then from the ARP reply, obviously the switch is able to kind of learn, right, that the MAC address A is accessible through this port channel 3, right. So it will have a mapping like this, port channel 3, right. This is present, right. This is all well and good, right. But what if we all know that the MAC address table kind of flushes out much quickly, right. The ARP table kind of stays for long, so, right. So as of now, this is the current scenario, right. So the ARP table on the end host has this mapping that this particular IP is at this, and this MAC address mapping is present. And ARP table, generally the timeout is about 4 hours, and MAC address table is probably like, I don't know, 3 minutes, 4 minutes, whatever, but a relatively shorter period of time, right. So after probably 3 minutes, 4 minutes, what is going to happen is this entry is going to vanish, right. But this entry will still be there, right. So the next time I'm trying to do I'm trying to send some traffic, right. What is going to happen? This particular switch, right, doesn't really know where A is, right, because the MAC entry has been flushed out, right. And the other problem, like I said, this particular system doesn't use the source, this particular MAC address in the source of Ethernet header. It doesn't use, right, in the source. So if this particular system is not using this MAC address in the source, there is no source learning happening here. So there is no way this guy is ever going to learn that A is present over here, right. So this is a problem, because what can happen is, in future, if this particular switch gets any frame destined to A, right, what this guy will end up doing is flooding, right. He'll do unicast flood. It's basically unknown unicast, right. So it's going to just do flooding. So if there are some other ports connected here, it's just going to flood it. Now the solution for this is what Arista has, and this is something interesting for me, because I got to know only after looking at the packets, right. So what Arista does is, if you keep on observing the packet captures, I kind of looked at it for like a couple of minutes to kind of get it. Every few seconds you can see there is a gratuitous ARP which is sent, right. And let me scroll down here as well on the left and right. You can see very regularly. I mean, either you will probably see it either on this link or this link. You can see here, now it is appearing here. So you can see the gratuitous ARP is being sent, right. And if you look at the packet, right, if you look at the gratuitous ARP, you can see the gratuitous ARP is basically sent from the source MAC address is nothing but the virtual MAC address, right. So using this gratuitous ARP, right, our switch, which is there here in the middle, right, is able to continuously keep a track of the MAC address. And that's how, if I show you the MAC address table, it is able to kind of learn that this virtual IP is that virtual MAC address is present, on the port 3. So this is again a very small Easter cookie kind of a thing, like a small tech nugget of sort, which you'll probably not find it anywhere in the documentation, but because I was kind of going through the packet captures, I kind of was able to spot it. But that's how they're basically solving the problem of flooding, right, unknown unicast flooding, because the bottom line is that this particular MAC address will never be used for any of the for any of the packet, right, or in any of the frame, right. And that's what we really saw here, right. When we looked at the ICMP reply, you saw the ICMP reply which is coming from the gateway. You can see the source MAC address is not the virtual MAC. It is basically the physical MAC of that particular SVI, right. So, or MAC of the SVI, not physical but MAC of the SVI. So there is no scope for any switches to learn the virtual MAC address, right. So to solve that problem, what Arista does is they basically send this gratuitous ARP, and you can see this is sent very frequently, right? And because it is sent very frequently, you can see these are continuously sent. Basically, the MLAG the VARP device is continuously telling to the rest of the world, hey, this is my MAC address, right? This is my virtual MAC address, and this is the mapping, which I have. And because of that, the tables are getting written. The MAC address table is getting written, and the switches are able to send the traffic to the right interface. All right, so we might have gotten distracted a little bit, but just want to kind of close the loop on that. But that's basically something very interesting. Again, the other thing is, maybe after this, excuse me, what you can also do is you can explore running the same thing but without MLAG, right? Basically, what I want you guys to probably explore is go see if you can use VARP without using MLAG, and it works, right? Only difference is what you'll end up doing is, I just take my pen here again. What will end up really happening is, so now you'll not have a MLAG, so you'll basically not have a port channel over here, right? So this will be a L2 link, this will be a L2 link, a normal trunk link, this also will be probably a L2 link, just trunk links, right? And for a minute, let's assume that you don't even have this link, right? Let's say this link is not even present. So what will happen is, but you have VARP enabled here, VARP enabled here, right? So on this switch, what you'll end up doing is this particular MAC address which you see, right, for some seconds it gets learned on this interface, and after that, it gets learned on this interface. So continuously, if you look at the MAC address table here, it will continuously be oscillating Ethernet 3, Ethernet 4, Ethernet 3, Ethernet. So I mean, based on which is the latest gratuitous ARP which I have received, because like I said, right, the gratuitous ARP are sent out every few seconds. I think it's every 10 seconds. So which is the latest one, based on that, the MAC address table will be updated, right? So the packet which is coming here, either it will go like this or it will go like this, based on what is the latest update which we have received from the gratuitous ARP, right? So but bottom line, VARP works. So if you have just without MLAG, you just have two switches, right? You can still use VARP, right, which will give you like the active approach, and you will basically you don't really need to use MLAG always with VARP. You can use VARP without MLAG as well, but just remember that the MAC address will keep on switching. There'll be a lot of MAC moves, right? The MAC address will first learn on this interface and then on this and back here, so it keeps on switching between both the interfaces. All right, so just wanted to kind of, I think that's mainly what I really wanted to kind of talk today. Hope this was useful. I mean, a quick lab on how you can kind of get things running, right? The CLI is very industry standard CLI, so with EOS CLI it's pretty straightforward, right? Just to summarize, what we did was we basically talked about MLAG, we talked about VARP, how to configure both of them. We also had a bit of routing here on the top, and to kind of test our scenario from this end host, we kind of sent packets first to the gateway, and then we also sent packets to the loopback interface here, and we made sure connectivity works. We also looked at the packet capture, and we saw something interesting where the VARP MAC address is never used in the source part of the Ethernet frame. It is always used in the destination. To kind of prevent the problem of flooding, we basically use gratuitous ARP, right? The VARP devices continuously send the gratuitous ARP to make sure that the switches, the L2 switches, are updated with the MAC address of the virtual ARP MAC address to prevent flooding. Okay. So thanks a lot for watching, and I'll see you again soon with a new lab. Bye.